Human brain, it learns by experience. And this experience, it comes to you in the form of the data that you observe around you. So the brain, it becomes better with more data. In other words, it becomes better with more experience. So for example, if you have been studying arts, you've been exposed to more arts, you become artist. What if you've been exposed to a lot of music? You've been studying music, you become musician. If you've been studying plants, flowers, you become botanist. Your machine learning model, it works on exactly the same principle. You feed it data, and the type of data you feed, it's going to become trained machine learning model on that type of data. For example, if you feed iris flower data set, this is going to become an expert or trained on iris flower. It's going to be expert on recognizing iris flowers. So here's the task given to you. You are given a data of iris flower, this one right here. So your job is to design a machine learning model that would become expert on recognizing this iris flower. In other words, your machine learning model should be able to recognize the type of flower. Is it setosa, is it versicolor, or is it virginica, based on the input. Your input would be your sepal and petal dimensions. In other words, you will be supplying your sepal length, sepal width, petal length, and petal width. Based on the input of these four dimensions, you have to predict what the species is. Is it going to be virginica? Is it setosa? Or is it versicolor? So this is the general idea of machine learning workflow. First, you collect your data. You will have features that will be represented by X, and then you will have target, the one that you're trying to predict, that will be your Y. You split your data into training and testing. Training and testing. You feed your training data to your model. Your model becomes trained machine learning model. Then you feed your X test, that will be your testing data. It goes to the trained machine learning model and it makes a prediction. This is your Y prediction. Now we compare this Y prediction with the Y test. That would be this one right here. By comparing these two, we evaluate how good our model is. Now to show this process, I'll be using scikit-learn package that comes from Python. You can use any other package. You have R script language, that's another one, or you can use any other language of your choosing. So first thing I'm doing, I'm loading my data. In this case, I'm loading iris data set, and I'm separating my X and Y. So X will be my sepal length, sepal width, petal length, petal width. These would be my X. My Y would be my species. And then I'm printing the shape of my data. So in this case, I have 150 records so far and total 5 columns. So this right here is a sample taken from the iris flower dataset. This one has total 150 records, and there are three types of flower right here: setosa, versicolor, and virginica. And each flower has total 50 records. So this is your X, and this would be your Y. X is called features. Another name for that is independent variable. Y is called target or response or label variables. Another name for that is dependent. Well, the reason it is called dependent because Y is a function of X. Step number two, now you split your data. From sklearn, there is an inbuilt function, train test split, that will actually split your data. So you supply your X, supply your Y, this is your data right here, that would be this right here. And then you also present your testing size. In this case, I'm specifying that, hey, I want my test size to be 20%. So this way, it splits your data. Now you're gonna have a training data and a testing data. So you will have four equal parts: X train, X test, Y train, Y test. The shape of your training data in this instance is 120 comma 4. In other words, there are 120 rows and 4 columns. For your X test, there are 30 rows and 4 columns. So now your data has split into 4 equal parts. X train, that would be this right here, something like that. And then you have Y trained, that would be this part right here. The other part would be your X test, that would be this one right here. And then Y test, that would be this part right here. Step number three, now I train the model. That would be this right here. So in this case, I'm using random forest classifier. This is my model. And in this case, I'm calling this fit inbuilt method. In this case, I'm supplying X train and Y train. That's going to train my model. So this is my X train and Y train that goes into the model, and the model gets trained. So this is the data that is fed to the model, the training data. You have X train and Y train. These two data, they go to the model. So after my model is trained, I want to make a prediction on just 2 samples. So randomly, I just went to the file and I picked up 2 samples. So these are my 2 sample values: sepal length, sepal width, petal length, and petal width. This one actually was taken for Setosa, and then I took another value, same value, and this time I took it for Virginica. And I'm converting my sample into data frame format, and then I'm asking the model to make a prediction. And it makes a prediction right here. And I print out the prediction, and it makes a prediction that the first one is Setosa and the second one is Virginica. Well, that's matching. The actual was Setosa, it makes a prediction of Setosa. The second was Virginica, it made the right prediction. Step number 4, now you feed the test data to your model. This one right here. After you feed, it's going to make a Y prediction. That would be this right here. Step number 5, now I evaluate the model. That would be this part right here. From my sklearn, I'm importing accuracy score, and in my accuracy score, I'm feeding the Y test and Y predicted. So in this case, that would be this. I'm feeding the Y predicted, and I'm also feeding the Y test. And it actually compares these two value, and it gives me the accuracy. And the accuracy is 93%.